This is the penetration testing report for Charles Bank, and now we are going to elaborate the working and what the attacks that found and recommendations. So all we discuss here, this is the executive summary, what identified high risk issues and like SQL injection, and what are the prevention mechanisms and key audits. And now this is the technical summary where we have key findings and key recommendations are mentioned here. So these are the findings. From first, we found SQL injection attack. So the risk level is critical, along with likelihood is very likely, and consequence is major. So basically, this is SQL injection light attack, and here the method which is used is get method to retrieve certain specified resource using query. So what is the impact? So here you can see that basically the URL of the web page includes a query parameter that appears to be an attempt at SQL code injection, like a syntax error. Basically, message along with the database tone, which indicates that the input was interrupted as a SQL code. And this is a clear sign of vulnerability to SQL injection attacks. And you should make sure to prevent this kind of attack, that all users input are validated and sanitized to prevent such kind of attack. So here, as you can see in the screenshot, here we have a SQL query and syntax error are shown here. So this is the problem that we've determined in this. So now another vulnerability that we discovered, SQL injection. Basically, the attack was attempted using the post method, and which is commonly used to submit data to be processed and to specified resource. And actually, it displays the payload. As you can see, this is the payload, and using the attack including code 1 equals to 1, which is a classical SQL injection technique. Basically, it manipulates the query to return true on all cases for all rows, with potentially exposing all the data in the database. And it contains result from the test suggesting that the attack was able to modify certain parameters and using Boolean condition. This is the Boolean logic as we apply to check the condition would be true or not. So we found that the condition is true, and we added a particular payload here, and the page will appear after using this query. So you can see this. You can see this is the login page. After executing this query, we successfully found the login page. And this is the problem of SQL injection, because we add some payload with logical Boolean condition, and the page is appear. So the third vulnerability that discovered is the cross-site request forgery. Actually, this is a kind of attack force a victim to send a HTTP request to a target site, and without their knowledge or intent performing actions as what the action they want to perform. So here, anti-CSRF tokens were not found in the HTML submission form. The attack method basically mentioned is a get, which indicates that the only attack could be carried out simply by getting the victim visit as a URL, and the form method is post, and the absence of anti-CSRF tokens in the HTML form is found that is a common security measure to prevent CSRF attack. So note it down that their absence suggests that the application is not checking for a token when processing the form submission, making it vulnerable to cross-site request forgery attack. And here you can see from method post, the form method is post, which is used for the submitting data and to be processed to a specified resource. So another important thing, CSRF attack often targets two types of requests because they can cause a change in the server state, like updating or like updating credentials, passwords, or anything, which is making a transaction. So this is a very important thing, and we found these vulnerabilities. So as you can see here, this is the screenshots, and you can see this is a URL, and as you attach the certain values, so you can see the page is appeared. So this is not a good sign for the web application. So now move on. Well, we have another discovery, which is cross-site scripting. Basically, it allows attacker to execute malicious scripts in a victim browser, and which appears to be coming from the site that the victim or that the user is currently visiting, basically. And what is the impact? So basically, cross-site scripting can be severe as it may compromise sensitive information, including session tokens, cookies, or other kind of data. So here we talk about this evidence. So basically, this is a piece of JavaScript code that has been obfuscated by using mixed case in the script and to bypass simple text filters that are case sensitive. So when this code is injected into the web page and the browser, it will execute the alert1 command. So as you can see in the screenshot, let me show you. So this is the alert1 command. Basically, this tag is used to define a client-side script in JavaScript. And alert1 is a function call that creates a pop-up alert box with the number 1 displayed in it. And another important thing, in the context of cross-site scripting attack, this code would be inserted into a web application's output without proper validation or you can say sanitization. So when other users visit the compromised page, their browser and their browsers would execute the script, resulting in the alert box appearing. So this is a winning example, but attackers could replace alert 1 with malicious code that steals session tokens, cookies, or any kind of sensitive information that are reside in the database. So this is the vulnerability that discovered. Now we have another vulnerability, vulnerable JS library, JavaScript library. Actually, the outdated jQuery version, like 3.2.1, is identified as the source of the vulnerability, and the plugin version 3.2.1 is reported as vulnerable from other sources like WhatsApp or something, and due to known security issues with that version of jQuery. And here, get method indicate that the vulnerability could be exploited via simple HTTP GET request, and this is the evidence basically suggests that the application is using an outdated version of jQuery, which is known to have vulnerabilities. So you can see as we execute this, this is the error message 404, and you can see this is the error message 304, as I mentioned here. So this is another vulnerable thing that could be compromised. So here I mentioned some recommendation like upgrade the library to the latest version. Because about application error disclosure vulnerability. So So basically, the risk is described as low, and the likelihood of encountering this issue is likely, and the consequences of such an error is considered as minor. So let's discuss basically the error message here could disclose sensitive information such as the location of the file and that will produce the error. So this information might be used by an attacker to launch further attacks and find vulnerabilities within the system. So here, as you can see, HTTP 1.1500 internal server error as evidence we discovered. So basically, the it indicates a server-side problem that prevents the website from fulfilling the request. And this is a generic error message that does not provide any specific details about underlying issue. And it could be caused by various server-side problems such as a misconfiguration, failed database connection, or you can say script errors. So for that reasons, this error could be produced. But this alert could be a false positive if the error message is found inside a documentation page. So here you can see you here we have an error HTTP 1.1, and this is a get method which is used here. So basically, as you can see in the URL, we use some query attached with this, and the windows appear. But this is the main issue because this HTTP 1.1500 is server error. So why it appears? So this is the problem. But after you see that if you log in this page without that URL, as we use here btn equal to confirm, and you can see this window appears. But normally we use this URL, so as usual it appears. It should appear. So this is the problem. So this could be cause of vulnerability and could be exploited by the attackers. So well, we have another issue, content security policy, and the risk level is medium, likelihood is likely, and consequence is moderate. So basically, content security policy header not set issue, which is a medium risk, and it is a kind of a browser feature that helps prevent certain types of attacks, including cross-site scripting, data injection, and so on. And the risk is categorized as likelihood and consequences moderate, as we discussed. And without CSP, basically, website is more vulnerable, which can lead to the theft of sensitive information, session tokens, cookies, and any other kind of credentials. So here, this is an important thing. We discovered the evidence. Basically, this code snap is shown as an example of a vulnerable point due to lack of CSP. Basically, the absence of CSP header means that the browser will not enforce restrictions on where the content can be loaded from. And this makes the application more susceptible to the cross-site scripting attacks and cross-site request forgery, where malicious scripts can be injected. So the specific code snap is likely part of template system, and you can see here it generates URL for the login page, and without proper sanitization and CSP in place, this could be exploited to inject malicious content. So this is an important factor and the vulnerability that we discovered. As you can see in our code snippet, this is the code snippet that could be cause of exploitation of the application. So make sure use proper CSP to validate these kind of queries. Now, lastly, we have authorization authentication issues. The risk is categorized as medium and with likely and consequences major. And authorization and authentication basically are mechanisms that are very necessary for verifying user identity and permissions. And basically, attackers could gain access to your account privileges, sensitive data, and systems functions. So there's potential for private information disclosure, leading to privacy violations and compliance is your risk. So basically, the Flask app appears to be running debug mode on a local server, which is not secure. But the production environment, this mode can expose sensitive information and debugging capabilities to potential attackers. One more thing, the option list all accounts, social, and delete accounts. As you can see in the web page, we have list all accounts and delete account. Basically imply that there might be insufficient access controls. If these actions can be performed without proper authentication checks, it could lead to unauthorized access and potential data breaches. The input field for account name suggests that user input is being directly used in the application, and if this input is not properly sanitized, it could be exploited through SQL injection or other forms of attacks to gain unauthorized access to the database. And you can see the registered username is clearly shown here. So this could be cause of disaster or exploitation for the application. Well, this is the end, and this is a summary of alerts. How many alerts for criticals, for high risk level, for medium, and same for low level. So this is the appendix. So hope you understand. Thank you.